Okay, today we're going to talk about FMD, and we're specifically going to focus on the HVAC portion of FMD. Now, the last time we did a short talk on FMD, we used Baker Petroleum, and I think they had seven locations online at that time. And right now, they've increased their locations with us, and it looks like they have 9 out of 10 stores online. Today, we'll take a look at the Rehoboth store, store number 5, and I'll click floor plan to get us to the store. Okay, so this is the standard view of Microthermo or Parker FMD, and we're going to be taking a look at HVAC today. We'll take a look at the rooftop units. So what we do is we go to the current store. In the drop-down, we choose equipment, and let's take a look at RTU office, and I'd like to go to the process view. Now let me explain a few things in the process view if I can. Let's start at the top of the presentation. What we do is we give a virtual look of the rooftop unit. Right now you can see the fan is running, cooling is off, and heating is off. What I'm going to do right now is I'm going to go into configuration. I'm going to go into heating, and I'm going to move the heat set point up just a tad so that you could see the unit fire. I'll do it to 72.2, and I'll hit apply. Okay, configuration has been saved successfully. What has happened is I've actually made that change in the cloud, and then periodically the smart nodes at the Rehoboth store look to the Microthermo cloud, they see that a change has been made, and then they affect that change. So let me go back to the process view. Hopefully, yep, I bumped it up just enough. You see now that the heating is on. We get a confirmation that it's on. We also get a proof that it's on here. And right now the heating circuit is drawing 20 amps. So let me start at the top of the diagram. We have fan, cooling number 1, heating number 1, and right now we're in the mode of heating. The top information we aggregate so that large chains can collect this information and use it as key performance indicators. What this runtime is up here is the amount of time the fan has run since this smart node has been actuated to monitor and control the rooftop for the office. So the fan has been on almost 1,000, just call it 1,200 hours. Cooling right now is off, but since we've started it up, it ran for 67 hours and 50 minutes. And the heating is currently on, and since we started the node up, it's run for 922 hours and 34 minutes. The purpose of aggregating this information for those who wish to use it, they can track all of their rooftops per se. How long does it run before they have a problem with the main fan in the unit? How long does it run before they have a problem with either the condensing fan or the compressor for the air conditioning? How long does the unit run before they have a problem with the gas valve, let's say, or a failure of the heat exchanger? If you collect all of that information, if you have a very large operation, what you could do is take a look at the performance indicators and do some predictive maintenance. Why let the unit fail and have no heat in the store if you can beat it to the punch and realistically say that, hey, our units seem to run 25,000 hours before we lose a condenser fan, or they run 45,000 hours before we lose a compressor for the air conditioning. I'm just, creating numbers right now, but again, it will depend upon the location. It'll depend upon the company. But again, that's the beauty of aggregating all of these numbers. You can use them to do some predictive um, maintenance on your stores. Okay, so you have the fan, cooling, heating is now on, and heating mode is actuated. Let's take a look at this graph right here, excuse me, this bar right here. Schedule is normal. Outdoor temperature 35.3. Indoor humidity 27%. The dew point is 36 degrees. Now they have two space temperatures in this store. So the space temperature in quadrant number 1 is 71.9 and indoor temperature 70.2. And what we're doing for them is we're averaging the two indoor temperatures, and we get an average of 71.8 degrees. And at the bottom, going from left to right, we see return air is 69.5. The effective set point is 72.2. The control temperature right now is 70.2, and the supply temperature coming to the store is 83.6. So there's a lot of valuable information on the real-time process view. Okay, return air is important. Supply air is important. Is my fan running? Yes or no? And am I calling for cooling or am I calling for heating? Now let me direct your attention to the bottom of the animation, and here's my runtime and cycles. Since midnight, I've run the fan for 13 hours. Since yesterday, our maximum count is 23 hours and 59 minutes. Obviously, it's the middle of winter here on the East Coast, so we haven't run any cooling at all. And our runtime on the heating since midnight has been 10 hours, 9 minutes, 7 cycles. And since yesterday, our runtime is 21 hours, 56 minutes for a total of 8 cycles. All right, this is the process view. Another view which is helpful is the graph view to see how the rooftop unit is performing. And you have to select the items that you want to view. So I'll hit the drop down. And let's go RTU office and supply air temperature and RTU office return air temperature. And I'll click it. It's going to take a while to build that information as we pull it from the smart nodes. And there you go. You see in green is indicated the return air temperature, and in blue is the supply air temperature. And as you would suspect, when it's calling for heating, your supply air temperature is warmer than your return air temperature. And here you're seeing some cycling of the unit, which if I was the customer, I would want to understand why there was some cycling. And other useful information is a minimum return air temperature has been 67.4, maximum return air temperature 71.4, and then my supply air temperature minimum has been 65.8, maximum has been 85.3, and my average has been 79.5 of supply air temperature. So let's go back to the process view, take a look at that one last time. And again, we see we're still calling for heating, and we have a supply air temperature of 84. Now what I'm going to do is I'm going to go back to configuration, and I'm going to return this to the temperature that my customer had originally programmed. So I'm going to go to the heating tab, and I change this to 72.2, and I'm going to back it down to their set point, which was 71. I could simply type it in, but you could use the drop down arrows. 71 degrees, and it's a dead band of 1.5 degree plus or minus centered on the set point. And I hit apply. And then I get my handshake. The configuration has been set. And if we had time, if we would want to do this, we could take a look at the process view, and we could watch this turn off. because now, of course, my control temperature is 70.3, so I might actually run for a while longer until I satisfy temperature. But what I'd like to do in this class, I want to show you how you could use FMD for troubleshooting. So a couple of days before I recorded this class, I got a call from a customer, Martin's. They do a lot of MT Alliance with us, but they do have two convenience stores. It was a test for them before they were acquired by a larger company. They thought they might build a convenience store, so they did build two before. So here is convenience store number one for Martin's. As in the other store, it's showing exactly the same. Here's my total runtime for the fan. You can see this store has been running a lot longer. Here's 11,634 hours of cooling, 9,890 hours of heating, etc. Excuse me, that's cooling too, and 999 hours of heating. Now, this store had a problem. They got a call from their employees that it was cold and they felt like they had no heat. So let me go to the graph. Got to wait for the internet to catch up. And it's going to default to today, which is the 18th of February. And I'm going to drop down what I want to show. I would like to show RTU number one. I'm going to do return air temperature. And I'm going to do supply air temperature. And I'm going to click it, wait for it to build. And there we go. All right, so now we're taking a look at the unit. This is the temperature of supply air in blue, return is green. So it fires for a while, satisfies, stays off. There's a call for heat. It fires for a while, satisfies temperature, and then it goes off. This is the type of graph that you would expect to see. But as I mentioned, there was a call for a problem. So let me go back in time. Let's go back to the 15th and see what the graph looks like, and then hit OK. Okay, it still looks like it's working fine here. So maybe this was a few days earlier than I thought. So let me go back to February 11 and hit OK. And again, we keep this history just for this reason, so you can go back and see what was going on in the store. There you have it. So supply air temperature is blue and return air temperature is green. What's wrong with this picture? The supply air temperature is very, very cold, and the return air temperature is warmer, probably just because of the actual heat generated in the building by refrigeration, lighting, the people inside, etc. But this is obviously a problem. Average return air temperature 60.9 and the average supply air temperature 53.5. So that's a problem. So let me go forward in time a little bit. And I actually called Julie, the gal that takes care of operations for Martin's, and she logged into my computer with me, and we looked at these graphs together. And she called one of her maintenance guys immediately upon seeing these graphs. And long story short, he was able to fix this within about an hour of arriving at the store. Boom, here's when it started working appropriately again. It actually was a faulty gas valve, and even though we were calling for heat, the gas valve was not opening. So unfortunately, we were having very cold air pour into the building. But now you can see he fixed it, and once he fixed it, we started to get supply air temperature that went up to about 100, 105 degrees, satisfied, dropped off a little bit, came back on, so on and so forth. So that's the beauty of FMD. It allows you to troubleshoot in real time and then go back historically. So what I did with Julie is I kept going backwards on the graph and found the time and date of when the system stopped working so that they could verify that. And then again, of course, they called one of their maintenance technicians. He went out and fixed the unit. As I said, it turned out to be a faulty gas valve. So let's go back to Baker. It's still calling for heat. Let me make sure that I save the configuration properly because I don't want to cause a problem for the customer. Nope, the set point is still 71. That's what it was before I changed. Let's go back to the process view. And we're getting close. We're at 70.9. Effective set point is 71. If we had some time to take a look at this, we would see that this lightning bolt here would go away. The amperage would go down to 0, indicating the proof says off, and we're not pulling any amperage for the heating cycle, and then the unit would not be in a call for heat. So again, your total aggregate amount of runtime is at the top. Your cycle time and runtime in the short term is on the bottom. Here is your real-time figures for what's happening with the specific rooftop. And here are your information for what's happening in the space. Indoor temperature 71.8. Indoor temperature 71.0. Average indoor temperature 71.8. So there you go. Let me take this back to the floor plan view. I always like to leave the store that way. And as always, it's been a pleasure doing this class for you. If you have any questions, my email address, cjcunliffe, CUNLIFFE @parker.com, or my cell phone, 908-415-9883. Thank you for watching this short class and a little bit of housekeeping. Let's hit disconnect here. Are you sure you want to disconnect? Okay. And there you go. All right. Thank you again for your time. It's been a pleasure. Look for more classes in the future.